Have a nice day. Welcome to the channel. I am Dr. S.K. Rajesh Khanna. In this video, I am going to explain what is a genetic algorithm, how the genetic algorithm can be used for optimization problem in a simple way. So, in this video, it is having some different parts. In this part, we are going to see what is optimization problems, that is, what are the simple problems, or we can say that which are the optimization problems. So that we have to first we have to discuss. Then we are going with what is genetic algorithm, what are the operators of genetic algorithm in this video. The next part of the video, we are going to see what is advanced GA, applications, similar approach, MATLAB for GA, and some simple hands-on sessions on this thing. Okay, first we will take what is a problem and what is a optimization problem. Okay, let us take, if I am asking you to write your name, then it is a problem. The solution can be, you can write your name with pen, pencil, crayons, or you can write it in a paper or in a board or in your wall, or anything you can do it. This is a problem. The problem may have n number of solutions. That solutions are also feasible solutions. Now I am adding a condition. I am calling it as a boundary condition. Okay, the name should be written using only pen. Then there is the limitation comes here, but you can use any pen. You can use black, blue, or red, or green, whatever the pen it may be, and there is no restriction on which you are going to write your name. Okay, so its solution is writing a name on a paper with only pen. We are not going to use crayons or pencil. So it is called as a problem. Problem means there should be some statement to be executed, and the statement can be executed. Okay, now comes to the constraint. What is the difference between constraint and boundary condition means boundary condition can be easily resolved, but constraint it is very difficult to resolve or difficult to satisfy. First let us take a constraint. I am asking you to write your name by sitting inside a tornado. It is not possible. By seeing, really or practically, it is not possible to sit inside and we can write it. Okay, this is called as constraint, but there is a solution. There we can satisfy the constraints. How? We can build a house of very strong enough, or we can build a cubicle which is very strong enough to withstand the tornado and other things, and we can sit inside. If you write your name, then it is the solution. So this type of problems only can be solved using genetic algorithm, or simple constraint problem can be usually solved using the mathematical equations itself. Okay, so let us come to a next example. Here you can understand what are the different types of constraint available, what is the necessity of the genetic algorithm. Okay, first I am taking a problem. In Chennai there is a town called as Tambram. From Tambram we have to go to our college or to the workplace. This is the problem. Okay, so one point to another point, that's all. I am giving the boundary condition. You have to go by bike or a car, and the distance should be in kilometers. Immediately, once if you give the problem, if you go from one location to another location, what we are going to do? We are taking our mobile phone and we are going to open the Google map, and we are giving the two places. Google map will give you a number of routes and we are going to travel in that thing. In the Google map, we can select whether we are going by bike or car or in kilometer distance. Okay, so this is what the boundary condition. The Google can sort out those things and it will give the solution. First constraint I am taking as the shortest time. This is what we call as the minimization problem. Shortest time means we have to reach the place in very shortest time. Okay, in Google there is two options. One is in the normal Google map, one is on the shortest time, one is on the shortest distance. Here I am selecting the shortest time. Okay, yes, it is possible, it will give the solution. Next I am saying that we are going in the route bypass only because we have to save the time. Okay, so the Google will give option for the bypass also. That is what we call as a satisfaction constraint. We can satisfy that constraint, it's not a big issue. And I am giving another constraint. In the path there should not be any toll gate, but it is called as a conflicting constraint. Why we are calling it as a conflicting constraint means you have most of the bypass having a toll gate. Without toll gate, bypass is very few. So if the bypass is there, definitely there should be a toll gate. bypass without toll gate is very difficult, which are the conflicting with each other. So this is what we call as a conflicting constraint. Next I am giving a thing called as I have to travel in the shortest distance. Yes, it is possible. It is called as the dependent constraint, because shortest time and shortest distance are more or less proportional. So the shortest distance depend upon the shortest time constraint. So it is called as the dependency constraint. Next I am giving a constraint, in my path there should not be any traffic. Yes, it is called as the dynamic varying constraint. What it means, because the traffic while starting Google may give the traffic details, but while moving the traffic may vary dynamically. It is changing, the traffic may be nullified or new traffic may be arised. So it is called as a dynamic varying constraint. And I am giving another constraint, I should have a tasty idli shop on my path. Yes, the Google will identify what are the hotels available on the path, but it is very difficult to identify the tasty idli shop. The Google may check with the reviews and it can say, but it cannot be predictable whether the idli is tasty or not. On the day idli is tasty or not, that it is not possible to predict it. This is called as unpredictable constraint. Next I am going with a I am saying that my vehicle is having very less petrol, so wherever it stops, wherever the petrol drains and the vehicle stops, there I should have a train or bus facility to reach my place. If you say like this, it is a non-linear constraint, because the Google map doesn't know how much petrol is available in my vehicle, how much fuel is available, what is the mileage of the vehicle, or when the vehicle is going to stop. This cannot be predictable. And at the same time, if the vehicle stops, whether there is a bus facility or train facility or the bus stop or railway station nearby or not, that is became a non-linear things. Okay, next I am saying the I am giving a constraint that my friend is reaching the same place in 45 minutes. My travel time should be less than that. If I give the constraint like this, it is called as inequality, sir. My friend may travel in some different vehicle, or my friend may travel in with high speed or low speed, but it is my constraint, my vehicle, my speed is entirely unknown to the Google Map. So it became inequalities. We cannot compare the two things as a constraint. So in this, why I am giving this example means, here you should understand what is my minimization function or what is my maximization function. Next you should know the different types of constraint: satisfaction constraint, conflicting constraint, dependence constraint, dynamic varying constraint, unpredictable constraint, nonlinear constraint, inequality constraint. If you give all these constraints for a single problem, definitely it will not be possible to solve using the standard available mathematic techniques. It will be very difficult for it. So that only we are going for a evolutionary algorithm, that is the genetic algorithm. Now the same example, now what the GA will do, or what the optimization will do, means it will create a solution space. Solution space is nothing but a Chennai city, because the two routes what I am selected is in the Chennai, so the solution should be in Chennai only. So I am taking it. The Google used to give three routes for the user most of the times. One is on the shortest time, another is on the shortest distance, or another is without traffic, like that. Okay. Now my objective is to travel in the shortest time, so my objective function f of x is minimization of the time in the travel. Okay, the Google is giving some answer. That answer, if you see, it is giving 51 minutes. National highway, there is no tolls, 25.4 kilometer, less traffic, 3 hotels available, public transport also available, only 6 minutes difference between you and your friend. If it is giving the solution like this, it is possible only by the optimization techniques. Okay, what is the difference between the mathematical problem and optimization approach? If there is a real-time problem, and if you made some assumptions, and if you simplify the problem, and then if you solve it, it is called as the mathematical problem. Okay, if you take the optimization approach, it will not do any assumption, it will not do any simplification, just a box in which you have to put your real-time problem, and the box, optimization box, will give you the solution. So it will replicate the exact real-time problem. Okay, second thing, in mathematical problem you are used to get the same answer whenever you solve it, wherever you solve it. But in optimization approach, it is giving n number of different answers for every trial. So that is the difference between the mathematical problem and the optimization approaches. Now let us take another example, spur gear design. Gears all you know very well. In this I want to design a gear. Okay, my objective is the gear should be very smaller in size, it should be of less weight, it should give higher efficiency, and it has to transmit more power. Okay, the first two objectives, the minimization objective, second two is the maximization objective. Once if you apply, once you able to achieve the objective 1 and 2, means it is not possible to get the objective 3 and 4 because they are the conflicting. So this type of problem is called as multi-objective problem, because minimization is there, maximization is there. Sometimes there may be a correlation between these two. Suppose I want to get a good surface finish with higher material removal rate, means again it is a multi-objective problem. Okay, so if you give the constraints, twisting moment should be less than the design value, bending stress, compressed stress should be less than this thing, and the temperature of the gear while service should be the limited range, even number of teeth should be there so that it is easy to manufacture, there should not be any noise, the gear doesn't require any lubrication. If you give like this, these are called as the constraints. Okay, so this is called as the why I am saying this thing means, as we discussed so far, the summary is the genetic algorithm can be used for multi-objective, multi-constraint problem to identify the solution, which is very difficult in solving using mathematical techniques. Okay, what are the different types of optimization problem? Now we can able to differentiate what is the problem, what is the optimization problem. Optimization problem, what is the solution? Mathematical technique, optimization techniques. What are the mathematical techniques? Why? What are the drawbacks of mathematical techniques that we learned so far? Now we are going to optimization problem. There are 5 types of optimization problems. Okay, one is P type, NP type, NP complete type, NP hot type, undesirable type. So let us take a P-type problem. It is a polynomial deterministic time. Okay, in AutoCAD, if you want to draw a arc, or in computer graphics, if you want to draw a arc on the computer screen, then it is called as the polynomial problem. It is very simple. What we studied in our +2, it is a quadratic equation or cubic equation or called as the polynomial problem. Okay, now let us take a quadratic equation, x square plus x plus constant is equal to 0. If you solve it, you can get two solutions that we know, minus b plus or minus square root of a square plus etc. So you are getting two different answers, okay, in quadratic by solving the quadratic equations. So this type of problem is called as the polynomial problem. It is easy to find out the answer in a deterministic time. Next type of problem is a non-deterministic polynomial solution, where the degrees is very high. At that time you can get the n number of solutions. Okay, even if I want to select a pixel in the screen, which I have to select it, there may be some conflictions. So this type of problem is called as NP hot problems. Next is the NP complete problem. Let us take a traveling salesman problem, or a Amazon boy delivering the packages. If you take it, it is also a non-deterministic, because the Amazon person or the delivery person who enters his office doesn't know where he has to deliver, what he has to deliver, when he has to deliver. It is a non-deterministic, and at the same time it is a polynomial problem. There may be n number of things. Okay, he has to travel to all the boarding point, and he has to give the mileage of the vehicle should be very less, and it should be delivered, all the products should be delivered in the day. If you say like this, it is called as NP complete problem. Complete means the things will be completed, but we don't know in which way. Next is the NP hot problem. In the NP hot problem only, there will be conflicting constraints, there will be inequalities like that. If you have n number of constraints, then the problem became the NP hot problem. Next is this the problem where the GA can give the solution easily. Okay, next is the undecidable problem. There is no way, even with the unlimited time and space. Okay, so each time this algorithm will give different solutions. Okay, that is we will discuss later. What are the solutions available for this type of NP-hard problem? There may be numerical methods, Newton-Raphson method like this, which can converge, converge slowly and reaches the optimal point. But if there is minimization and maximization in the same problem, this type of convergence is difficult. Next is the mathematical techniques which can be solved without constraint, with constraint, and with a number of constraints it is not possible to solve using mathematical techniques. Next is the non-linear programming techniques that is available. Again, it is a difficult thing. Stochastic method is the trial and error method which is followed by our olden researchers while finding the optimal solution for the problem with constraints. There is a hybrid methods. You can combine 2 or 3 methods and we can find the solution. There is a heuristic methods. They are modifying the existing solution to adapt with the problem. So that type of problem will give solution only to those problems, and it cannot be universal most of the time. Evolutionary method, that is a genetic algorithm, we are going to see the thing. Okay. Next, the search technique. We can classify the search techniques as a calculus-based, guided random search, enumerative techniques. If you take the calculus-based method, there is a direct method, indirect method, in which there is a Fibonacci series, Newton series like that. Newton series, there's a lot of methods are there to solve the problems. Okay, if you have the guided random search technique, there comes the evolution technique, simulated handling like this. In the evolution technique, one is the genetic algorithm. There is lot of techniques are there in the evolution technique, selective breeding, firefly, etc., etc. Okay, in genetic algorithm there is a parallel, there is a sequential, centralized, distributed, it will go like that. Okay, and if you take the enumerator technique, it is a dynamic programming techniques. Okay, now what they are if you take the research area in the optimization technique, initially the researchers are finding the solution with only trial and error methods. Okay, they are having the problem, they will solve it by trial and error method. Example, if you take some industries where we have to pack the machines in the lorries. So let us take a lathe machines, or let us take some computers. If you want to pack it, first they will pack in trial and error method, and they find out which position of the box or which position of the machine will yield the maximum utilization of that container. So this is what we call as trial and error method. Next we will based on the experience. Based on this packing, the persons are getting experience on that area, and based on that experience they started packing it. Okay, but in the experience method, what is the problem means, once that person is get retired, his knowledge goes off as such. It is not transferred to the juniors. So that is the problem. Next comes the optimization techniques. The optimization, it is what I mean is traditional optimization techniques. Lot of methods are available. Okay, that they are solving it, but multi-constraint it is not possible for them to solve it, or even if the multi-constraint is possible to solve it, will consume very high time. Okay, next comes the heuristic techniques, because this optimization technique cannot be applied to all the problems, and making the optimization technique which is more adaptable to the problem, that is what we call as heuristic technique, by modifying some operators or something. Next comes a big step that is called as genetic algorithm, which is the next big step we can solve it. Okay, what is genetic algorithm? It is a search technique used to find the approximate solution to the optimization problem and such problems. Okay, it is developed by Joel Holland. It is working with only the random number. It is simple and fast convergence, flexible to adapt in any format like decimal, alphabetic, whatever it may be. Okay, so this is what we call as optimization. As a summary, I will conclude this session. First, we are seeing what is meant by a problem. Anything which we have to do, that is called as a problem. And if there is some limitation to do the thing, that is called as boundary condition. If you give some specific requirement, then it is called as a constraints. In the constraints, there may be n number of constraints are there. First thing, it may be a satisfactory constraint, or it may be inequality constraint, or unpredictable constraint, non-linear constraint, conflicting constraint, dependency constraint, independent constraint. There may be n number of constraints. When this type of constraints is available, on the other hand, objectives. Objective can be a minimization objective, maximization objective, or neither minimum nor maximal objective. There may be multi-objectives. In order to solve multi-objective problem with multiple constraints, the mathematical technique might not yield the good solution, or it may consume, or the optimization technique will consume more time for solving this type of problems. So for multi-objective, multi-constraint problem, the best solution is the evolutionary algorithm, and it is the genetic algorithm. In the next video, I am going to explain what is genetic algorithm in simple terms. Okay, thank you very much for listening this video.